Hello everyone, and welcome to Earth Archives. Today, we're going to talk about a very mysterious planet in the solar system, Mercury. Let me ask you first, is Mercury really that small?
Mercury is the smallest planet in the solar system, with a diameter of only about 4,880 kilometers, which is less than half the size of Earth. Yet, it has a rich and dramatic story. This planet, located closest to the Sun, may be small in size, but plays an indispensable role in the evolution and dynamics of the solar system. Mercury's surface is covered with impact craters and steep canyons, showing that it has endured a long and intense history of collisions. These craters act like natural time capsules, witnessing the chaotic early formation stages of the solar system. Mercury experiences extreme temperature changes, reaching up to 427 degrees Celsius during the day and dropping as low as minus 173 degrees Celsius at night. These drastic temperature variations reflect the fact that it lacks a thick atmosphere, making Mercury an important natural laboratory for studying the interaction between planetary atmospheres and surfaces. Although Mercury is small in size, its rotation and orbital path exhibit fascinating physical phenomena. It takes about 59 Earth days to complete one rotation and approximately 88 Earth days to orbit the Sun, creating a rare 3:2 orbital resonance. This makes Mercury's day and night cycles uniquely unusual and a long-term focus of study for astronomers.
Wow, since it's so close to the Sun, the temperature must be really extreme, right?
Mercury is the closest planet to the Sun in the solar system, and also one of the celestial bodies with the most extreme temperature differences. During the day, Mercury's surface temperature can soar to an astonishing 430 degrees Celsius, hot enough to cook an egg, like being inside a blazing oven. However, when night falls, the temperature plummets rapidly to minus 180 degrees Celsius, as cold as the harshest winter. This extreme day-to-night temperature swing of over 600 degrees Celsius is a rare ultimate challenge in nature. The root of these drastic temperature changes lies in Mercury's lack of an atmosphere, which prevents it from retaining heat like Earth does. During the day, it's exposed to intense solar radiation and the surface heats up quickly. At night, without sunlight, the heat dissipates just as fast. This environment makes Mercury an excellent natural laboratory for studying planetary surface thermodynamics and the effects of having no atmosphere. Moreover, Mercury's extreme temperature variations pose challenges for future exploration missions. Landers and probes must be highly heat-resistant and able to withstand intense cold to operate normally in such harsh conditions. This has driven scientists to continuously innovate technology and design instruments and equipment that can endure Mercury's extreme environment.
Does it have an atmosphere? Can it help moderate those extreme temperature differences? Mercury is the closest planet to the Sun in the solar system and also one of the smallest in size. Because of its limited mass and gravity, Mercury has almost no atmosphere. The lack of a thick atmosphere means Mercury doesn't have a protective shield like Earth to block the Sun's intense radiation and heat, which is the main reason for the extreme temperature differences on its surface. On Earth, the atmosphere not only regulates temperature but also blocks harmful radiation like ultraviolet rays, creating an ideal environment for life. In contrast, Mercury's lack of atmospheric protection means that during the day, the Sun's intense heat directly hits its surface, causing temperatures to spike above 430 degrees Celsius. At night, heat quickly escapes, and temperatures plummet to minus 180 degrees Celsius. This temperature swing of over 600 degrees Celsius is an extreme natural limit unmatched anywhere on Earth. Additionally, without an atmosphere, Mercury cannot effectively retain heat from the Sun, and the heat rapidly dissipates into space. This makes Mercury a prime example of an extreme environment and an important subject for studying planetary climates and atmospheric evolution. By studying Mercury's extreme conditions, scientists can gain deeper insights into how planets form and change under different environments. The absence of an atmosphere also leaves Mercury exposed to intense solar wind. Solar wind carries charged particles that continuously bombard Mercury's surface, stripping away surface materials. This further limits the formation and retention of any atmosphere, keeping Mercury's environment extremely harsh and unchanging. Sounds like it's switching every day between a scorching oven and a freezing freezer. So, how long is one day on Mercury?
Mercury has many unique features in the solar system, and one of the most fascinating is its special relationship between rotation and revolution. The time it takes Mercury to complete one rotation is exactly the same as the time it takes to orbit the Sun twice. In other words, one day on Mercury equals about 176 Earth days, while it only takes 88 Earth days to complete one orbit around the Sun. This phenomenon is called a 3:2 spin-orbit resonance, which is very rare in the solar system and truly amazing. This clever ratio between rotation and revolution causes some regions on Mercury's surface to experience extreme day-night cycles. Because Mercury orbits the Sun quickly but rotates slowly, the Sun's light lingers near the horizon for a long time when shining on a particular spot, making the daytime extremely long, while the night is equally long and cold. This is one of the major reasons behind Mercury's incredible temperature swings between day and night. This spin-orbit resonance mainly results from Mercury's proximity to the Sun, where it is strongly influenced by tidal forces. The Sun's gravitational pull gradually locks Mercury's rotation speed into this specific ratio, creating a stable and unique motion pattern. This not only makes Mercury's astronomical characteristics a key research focus, but also serves as an important example in planetary physics for studying tidal forces and spin-orbit dynamics.
Wow, that's amazing. What about its density? It's such a small planet, wouldn't it be very light?
Mercury, although the smallest planet in the solar system, surprises us with its weight. Its density is second only to Earth's, which means it has a very large mass, actually heavier than many of the combined moons of Jupiter and Saturn. The key to this lies in Mercury's exceptionally large iron core, which makes up about 70% of the planet's radius. This structure makes Mercury a small but tough metallic planet. Scientists speculate that Mercury's unique internal structure may have resulted from a violent event early in the solar system's history. It's very likely that shortly after its formation, Mercury suffered a massive collision that stripped away much of its rocky outer shell, leaving behind a dense metal core with only a thin outer layer. This explains why Mercury's density is so high. Its mass is concentrated despite its small size. This high proportion of metal core not only gives Mercury a strong gravitational field, but also affects its magnetic field and geological activity. Although Mercury's magnetic field is not as strong as Earth's, it still provides evidence that its core contains a molten layer of iron, revealing secrets about the planet's internal structure.
I see. What about its geological activity? Does it have volcanic eruptions?
Mercury, the smallest planet closest to the Sun in the solar system, though small and geologically very inactive, holds a rich history. Unlike Earth, with its active plate tectonics and volcanic eruptions, Mercury's surface shows almost no modern geological changes. It's like a frozen time capsule, preserving precious memories from the early solar system. Mercury's surface is covered with countless impact craters that have remained for billions of years, much like the pockmarked surface of the Moon. These craters are not only evidence of collision events, but also reflect the violent environment during the early formation of the solar system. By analyzing the distribution and sizes of these craters, scientists can gain insight into the frequency and evolution of small celestial bodies in the early solar system. Unlike Earth, Mercury lacks a thick atmosphere and active crustal movements, so it cannot repair these impact craters, allowing them to remain so well preserved. This characteristic makes Mercury one of the most important bodies for studying the early environment of the solar system. Each crater is like an open page in a history book, telling us stories from billions of years ago in the universe.
I've heard that Mercury has some unusual landforms.
Mercury, this small but tough planet, is covered with all kinds of impact craters, and the most astonishing among them is the Caloris Basin, a massive impact crater. This gigantic crater is over 1,500 kilometers in diameter, taking up a significant portion of Mercury's surface, making it one of the most spectacular landforms in the solar system. At the center of the Caloris Basin stands a mountain about 800 meters high, formed by the crust rebounding during the impact, like a giant geological scar that testifies to the intense collisions in the ancient universe. Even more fascinating, the Caloris Basin is surrounded by a network of fractures and canyons radiating outward like spider legs, which is why scientists jokingly call it the Mercury spider. This unique terrain is extremely rare on other planets and showcases Mercury's special geological evolution and the crustal response to impact events. These fractures are not only marks of the impact force, but also reflect the peculiarities of Mercury's internal structure, sparking scientists' curiosity about its composition and development. The existence of the Caloris Basin not only gives us a direct sense of the violent impacts Mercury has endured, but also provides crucial clues for geological research. By studying these fractures and the central peak, scientists can infer Mercury's internal physical state and thermal evolution, further unraveling the mysteries of this planet's formation and development.
Wow, that's so cool. So, what's Mercury's relationship with the Sun like?
Mercury is the closest planet to the Sun in the solar system, at about 58 million kilometers away, making it the Sun's next-door neighbor. However, this close proximity brings extreme environmental challenges. Because Mercury has almost no atmosphere to protect it, its surface is nearly directly exposed to intense solar radiation and constant bombardment by the solar wind. This direct exposure makes Mercury a prime example of extreme conditions in the solar system and creates many unique space physical phenomena. The solar wind is a stream of high-speed charged particles continuously blown out from the Sun. When these charged particles strike Mercury's surface, they trigger a series of complex physical reactions, including ionization, ejection of surface particles, and even chemical changes. These processes not only affect Mercury's surface structure, but also provide scientists with a valuable window for studying the interactions between the Sun and planets. Because Mercury lacks a thick atmosphere or a strong magnetic shield, solar wind particles can directly interact with its surface materials, producing space phenomena similar to planetary storms. These include X-ray emissions generated by high-energy particle impacts and plasma environments created by ionization on the surface. These unique physical processes influence Mercury's own evolution and offer excellent examples for studying how solar wind affects planetary environments. Moreover, Mercury's extreme environment makes it an ideal natural laboratory for observing and understanding the interactions between planetary magnetic fields and the solar wind. Although Mercury's magnetic field is relatively weak, it is still strong enough to form localized magnetospheres. The collisions and interactions between these magnetospheres and the solar wind further enrich the complexity of Mercury's space physics.
How do humans study Mercury? Isn't it too dangerous being so close to the Sun?
Mercury, the closest planet to the Sun in the solar system, has always been a focus of scientific exploration due to its extreme environment and mysterious nature. Despite the harsh conditions, humanity's journey to explore Mercury has been filled with challenges and breakthroughs. The first close encounter with Mercury was NASA's Mariner 10 mission in 1973, which was humanity's first chance to unveil the mysteries of this planet. Mariner 10 sent back the first images of Mercury's surface, revealing a landscape covered with impact craters, and confirmed that Mercury has a massive iron core, an important discovery for understanding the planet's formation and evolution. With advancements in technology, the launch of the Messenger probe in 2004 marked a milestone in the study of Mercury. Orbiting the planet for nearly 4 years, it used high-precision instruments to create detailed topographic maps of Mercury, uncovering numerous traces of ancient volcanic activity, evidence that the planet once experienced geological processes. Surprisingly, Messenger also discovered the presence of ice in Mercury's polar regions, a remarkable finding given the planet's extreme heat. This discovery prompted scientists to rethink Mercury's environmental conditions and its evolutionary history. Now, the latest mission, Mythical, is set to arrive at Mercury in 2025. A joint project between Europe and Japan, this spacecraft is equipped with more advanced instruments and will conduct in-depth studies of Mercury's magnetic field, geological structure, atmospheric composition, and surface environment. Scientists hope that data from Mythical will provide a more comprehensive understanding of the planet's hidden secrets and further our knowledge of the early history of the solar system.
Polar ice? Mercury is so hot, how could there possibly be ice?
Mercury, as the planet closest to the Sun in our solar system, has long fascinated scientists with its extreme environment and mysterious nature. While daytime surface temperatures on Mercury can soar up to 430 degrees Celsius (800 degrees Fahrenheit), it's astonishing that ice has been found in certain hidden corners of this scorching planet. These icy deposits are located in permanently shadowed regions near Mercury's poles, areas that never receive direct sunlight. As a result, the ice can remain preserved despite the planet's intense heat. This discovery has completely overturned our traditional understanding of Mercury. In 2004, the Messenger spacecraft began detailed observations and research of Mercury, uncovering many secrets of its surface. The discovery of polar ice not only confirmed the complexity of Mercury's environment, but also offered a fresh perspective on the geological history of the inner planets in our solar system. This ice may have originated from comet or asteroid impacts, or it could be remnants of water molecules dating back to the early formation of the planet. Despite its small size, Mercury is full of surprises and holds immense value for exploration. Additionally, Messenger revealed Mercury's rich surface features and evidence of ancient volcanic activity. These traces suggest that Mercury once experienced significant geological activity. Though such activity has largely ceased today, the ancient marks left behind are crucial clues in understanding planetary evolution. The data from Messenger not only helped us learn about Mercury's internal structure, but also deepened our understanding of the formation and development of the entire solar system.
So, will Mercury always stay the way it is now? Could it get even smaller?
Mercury, the smallest and closest planet to the Sun in our solar system, is undergoing a slow yet profound transformation. Its radius is gradually shrinking. After years of observation, scientists have found that Mercury's radius has decreased by about 14 to 20 kilometers. This phenomenon is mainly caused by the cooling of its internal core. As the core temperature drops, the planet's interior contracts, and its surface begins to wrinkle like the skin of a dried apple, leaving behind distinctive geological features. Mercury experiences very little geological activity. It lacks the active plate tectonics and volcanism seen on Earth, which has allowed many ancient and well-preserved impact craters to remain on its surface. These craters offer valuable insights into the early history of the solar system. At the same time, Mercury is constantly subjected to the Sun's intense gravitational forces, which cause the planet's surface to experience ongoing stretching and compressing. This leads to the gradual shrinking and warping of the crust. One result of this shrinkage is the formation of wrinkle-like surface features known as lobate scarps. These ridges crisscross the planet and serve as compelling evidence of Mercury's slow geological evolution. In the future, Mercury's transformation will continue at an extremely slow pace. Since the core's cooling is a very long geological process, the planet's shrinkage will likely persist for hundreds of millions of years. Although the changes are gradual, this ongoing contraction holds great significance for understanding Mercury's internal structure, its evolutionary path, and the development of terrestrial planets in the solar system.
Wow, from what you've said, Mercury may be small, but it's truly mysterious. Mercury, although the smallest planet in the solar system with a diameter of only about 4,880 kilometers, less than half that of Earth, is far from insignificant. This planet experiences some of the most extreme environmental conditions. Daytime temperatures can soar to 430 degrees Celsius (800 degrees Fahrenheit), while nighttime temperatures plummet to minus 180 degrees Celsius minus 290 degrees Fahrenheit. The dramatic difference between day and night makes it one of the harshest, extreme challenge zones in nature. What's more, Mercury's unique rotation and orbit ratio is truly remarkable. It completes one full rotation for every 2 orbits around the Sun. In Earth terms, one day on Mercury, from one sunrise to the next, lasts 176 Earth days, while one orbit takes just 88 days. This rare phenomenon, known as spin-orbit resonance, has fascinated scientists and sparked deep curiosity about Mercury's formation and evolutionary history. Even more astonishing is that Mercury has an oversized iron core, making up about 70% of its radius, which gives it a mass far greater than other planets of similar size. This may be the result of a massive collision in its early history that stripped away much of its outer layers, leaving behind a lean but powerful, metallic heart. The planet's surface is covered with impact craters that formed billions of years ago. The largest of these is the colossal Caloris Basin, measuring over 1,500 kilometers in diameter. Its central peak and radiating fractures form a truly unique and striking geological feature. Although Mercury lacks a thick atmosphere to shield it from the Sun's intense radiation, it has become a key object for studying the interaction between the solar wind and planetary surfaces. Space probes such as Mariner 10, Messenger, and the soon-to-arrive Bepi-Colombo continue to unveil the mysteries of this small planet. From signs of ancient volcanic activity to the discovery of polar ice, Mercury's story is steadily unfolding.
That's the end of today's journey to Mercury. If you enjoyed it, don't forget to like, subscribe, and share it with your friends and family. Let's keep exploring the fascinating planets of our solar system together.